So please welcome Mrinal.
Yeah. Thanks, Scott. And thank you all for being here this early in the morning. Without further ado, let's talk about CasperLabs, something I'm very excited to do. We'll essentially cover two things today. First, I want to give you some historical context and explain the motivations behind us building what we're building. And once those motivations are clear, I'm going to talk about the key aspects and key properties of the platform that we're trying to deliver. An important, if we step back, what Ethereum did was monumental for blockchain technology. If you think about Bitcoin, it's a static ledger. And what that allows you to do is transfer money from one person to another, but you cannot add intelligence on top of it. What Ethereum proposed was, instead of referencing a static ledger, let's reference the state of a virtual machine. What this allows you to do is add conditional intelligence on top of this. So instead of just saying, I'm giving Scott Walker $10, I could say me and Scott Walker had a bet. I said the New England Patriots are going to win the Super Bowl.
Oh.
Those were the Americans groaning. I could actually program a contract that says, if the New England Patriots win, I owe Scott Walker $10, and if they lose, he owes, I don't owe him anything. And so the ability to have this intelligence is extremely important. Why are Bitcoin and Ethereum so beloved? It's not an accident that they're the two biggest protocols out there. They are completely decentralized. This decentralization, however, has come at a cost. So many people have tried to sort of circumvent the costs of decentralization, which manifest at transaction rates of 10 to 15 transactions per second. There are two mechanisms under which they do this, primarily. Mechanism one is they try to do it through some form of centralization. You either do this through delegation and voting, or you can do randomization and pick which validator does it. The second way is to have a layer 2 solution. The way a layer 2 solution works, as per the diagram, is transactions come in to the layer 2 solution. They're essentially batched and then posted to the blockchain. Neither of these are bad solutions, by the way. There are use cases where decentralization is not that much of a problem. And layer 2 solutions will be required regardless. I mean, they are on top of everything in our technology stack in the world. Visa has several payment processors on top of it. Salesforce has several integration mechanisms that are completely separate entities. However, we think you have to get layer 1 right. What we are proposing, which is slightly radical, is what if we could build a blockchain with neither of these compromises? Of course, this is not a trivial task, and now I'm going to talk about how we propose that can be done. Essentially, you need to do 4 things, and I'll go into these in detail. First, you need a virtual machine that works and is multi-threaded. Second, we have to move away from proof of work to proof of stake systems. Third, we have to offer a sharding solution that allows heterogeneity of the network. And by that, I mean different properties in different places. And finally, you have to have state-of-the-art tools like other software platforms have to enable rapid development, easy development, and make sure it's accessible to everyone. So let's go through the first thing. The virtual machine itself, we are proposing 3 properties. 1, multi-threaded and concurrent execution. What that means is transactions that are not dependent on each other should execute at the same time. So if I want to send Scott $10 and Alex wants to buy a carton of milk, those 2 things don't depend on each other at all. There's no reason why they shouldn't execute at the same time. However, if things are dependent on each other, you have to make sure you've built up your execution environment in such a way that they don't get into a lock. And so we are from the ground up built in a multi-threaded and concurrent execution environment. The second thing is we're huge believers in the ability to, as far as possible, formally verify things and be correct by construction. What this means in layman terms is if everything that your software project is doing can be represented by a mathematical equation, it is more secure and it is also more predictable. You know what the machine will do because you can write it down as an equation. And third, we think security is extremely important, and we use the object capability model. If you look that up, there's actually, this is the one time that the Wikipedia article is somewhat accurate. So don't feel bad about reading about this on Wikipedia. It was actually proposed in the 1960s. It's used by Microsoft, Oracle, Google, all major tech companies in their stack. And essentially, it's about keys and locks. You just make sure that the right people have the right keys to access objects, processes, et cetera. And so how does that translate into our architecture? One thing that we've done is all the green boxes talk about our blockchain environment, if you will. This is where consensus happens. This is where blocks are produced. And this is sort of how transactions and nodes are proposed to the network. All of this is written in Scala, and there's a reason for it. Scala is a functional programming language, whereby you can state every process as in a mathematical form. And what this allows is predictability. A function f with an input x, when run as f of x, will always have the same output. And this is extremely important. The second part of our stack, our execution engine, is the Rust implementation of WebAssembly. I'll go into more detail about some of the features this adds, but importantly, this part of the tech stack is already largely formally verified. There's been a lot of academic and computer science hobbyist attention to it, and so we know it works, which is excellent. And so Rust and Scala are really the only two programming languages as part of our stack, and that's by design. Now let's talk about proof of stake. For those who are following along in English, everything on the left is about proof of work, everything on the right is about proof of stake. The essential problem with proof of work is that 90 to 95%, I'm being a little loose with percentages here, there's a lot of academia around it, but 90 to 95% of all your processing power is being used to generate random numbers. Once these random numbers have been generated, they serve no utility after that. Only about 5 to 10% of your computational power is actually doing the useful work of running transactions. Whereas in proof of stake, that is switched. Most of your processing power is executing transactions. And this requires very different hardware stacks. You look at what a proof of work capital outlay looks like, it's mostly GPUs and ASICs. And the reason for that, think about what a GPU does. You know, it streams videos, it runs video games. That's the reason you have 60 frames per second. It's great at pumping out pixels, and so it's also really great at pumping out random numbers. On the other hand, for proof of stake, you need a CPU-centric system, which is sort of like the Intel processor you all have in your laptop or your MacBooks. And you also need to buy some of the underlying tokens. These are diametrically opposite systems, and transitions we feel could be fairly difficult. As you can see, they're very, very different. So what's the end result of this? Proof of work is less efficient, slower, but it's easy to implement in a decentralized manner. Proof of stake is faster, much more efficient, but really, really hard to implement in a decentralized manner. CBC Casper, we believe, is the breakthrough that can make this possible. And there is an excellent white paper if you go online, just Google CBC Casper. It's a heavy read, so you have been forewarned. But it's very evocative. Finally, let's talk about why sharding is important. If you look at every industry, they naturally evolve to give people a lot of choices. One size fits all doesn't work. If you could only order vanilla ice cream, you'd probably not be a fan of ice cream in general. And so one of my favorite examples is, in 1908, Henry Ford made a famous quote, "You can buy it in any color as long as it's black." And so think about Ford in 1908. One car model, one color, one configuration. Think about what Ford looks like today in 2019, just in the United States. So I just scraped the website. There's 30 different models, each one with about 5 to 6 different configurations and about 10 different colors. This is one car company in one country. In Japan, you have thousands, if not millions, of permutations of the cars you can buy. Think about how AWS and Azure work, which are probably the most widely used accessible compute platforms. They offer you many flavors of things, and this is why sharding is important. Scalability is nice too, but this is why it's really important. So let me give you an example. So under our system, you'd have a root shard up at the top. That's sort of your base level economics, base level performance. It'll have the most validators. It'll be the most secure. But let's talk about two shards that we could have under that have extremely different properties. You could have a storage shard. What do you want in a storage shard? You want it to be globally distributed, because if the lights go out in one city, you want to make sure that your stuff is still up. You don't care about speed that much, so you don't want extremely expensive compute, and you want cheap storage. Versus something diametrically opposite. Imagine a security shard, and by this I mean someone wants to fractionalize assets on the Nikkei. What do you want? What properties do you want there? You want it to be extremely fast. You want microsecond level latency, and you also need to make sure that every single validator is within Japan. Because if it's not within Japan and the data leaves the country, you'll be contravening local law. The ability to offer these characteristics and have all of these systems run by a single token and a single currency enables heterogeneity, and it enables the free market to take over and drive innovation. And we think this is extremely important. So talking about how we make all of this more accessible, I'm speaking to most of you through a translator. It's actually fairly amazing that many of us here probably speak different languages, but we're able to talk to each other. So a human analogy I like to use is, whether I say hello, ni hao, hola, annyeonghaseyo, namaste, after it goes to a translator, you all hear it as konnichiwa, and that's really, really powerful. The input language could be anything, and the output language is one thing that most in this room understand. We take the same approach to our architecture. How WebAssembly is analogous to this is your input could be in Rust, C, C++, C#. In fact, it's an open architecture that could allow, theoretically, almost any language to compile down to it as long as it fits within certain parameters, and the output is WASM bytecode. So this is about making our system accessible to any programmer. You don't need to learn a new language. Use the language you're comfortable with, and we'll make sure that our infrastructure is accessible to you. And we think this is a core principle to decentralization. On top of that, you need state-of-the-art tools for people to be able to build on this. One thing is IDE integrations. Different programmers like using different development suites. So integrating them is extremely important. Having state-of-the-art block and shard explorers is really important. As we talked about, shards are going to have different characteristics. And so when people want to find the shard that they want to deploy to, they need to have a set of infrastructure that helps them do that. Installing a node should be automated if we can. Think about this. How many of you have more than 5 apps on your mobile phone? Well, I guess pretty much everyone. The reason for that is you can open up Play Store, press a button, the app installs, and you're ready to go. The reason most of us don't have nodes or validators running is because it's a fairly hard process. And we believe it should be an executable where you punch in a few numbers and double-click it, like installing Windows. And finally, we think having state-of-the-art wallets out the gate is extremely important because people need to know that their assets are safe. Finally, just wanted to offer some parting thoughts. I think the first one is really important. I think what's great about the blockchain movement is we're all in this together. I don't view this industry as competitive, but more collaborative. Because it's open source and we talk to each other and the code is shareable, this will drive innovation at an extremely rapid pace, and it's something that we embrace. Second, we think it's very important to honor and give high regard to our antecedents and the people who enable us to be here, both blockchain and non-blockchain. If it weren't for Bitcoin, if it weren't for Ethereum, we wouldn't be here. These were massive innovations. If it weren't for databases, if it weren't for formal verification, if it weren't for the object capability model, we would never be able to build any of these things. Thirdly, I think the more inclusive we are as a movement, the better. Tribalism is a bad thing. We are blockchain guys, they are not blockchain guys, is not how we win the moment. The way we win the moment is everyone can be part of this community, and that's why we've embraced open architectures. Anyone can use this platform as core principles. We're going to be around here. Can everyone from the CasperLabs team please raise their hands? If you have any more questions for us, please reach out to us. We'll be around here most of the day. So I want to close with that. You can find us on Telegram. Thank you very, very much. I'm really honored for your attention. Thanks.
I think we might have a couple more minutes. I have a couple of questions for Mrinal. Before I asked, I wanted to see if anybody had any questions regarding CasperLabs, Ethereum scaling, any of the issues that we kind of brought up today. Yes, sir.
Sir, he's bringing over a microphone.
Hang on, one mic, sorry.
That was the best explanation of proof of work and proof of stake I have ever heard. Thank you very much.
Wow, thank you.
Thank you, you're too kind.
I'll ask the main question that I have, and we're all wondering, when do you expect the development process to be complete? When do you expect to have live testnet, live mainnet, kind of going forward?
Sure. Look, development is always fluid, sort of hedging already. Development's always fluid, but I think it's reasonable, like by mid-year, we should have a testnet up and testable. Now, when the mainnet launches, I'd rather answer that question with what the release criteria should be and what that typically looks like. We believe that it has to be adequately tested before it launches live. I think finding bugs later on is not good. So our release criteria will typically be 4 to 6 weeks of stability, no non-deterministic bugs. And if we've thrown a lot of contracts and a lot of attacks at it, and we get 6 weeks of stability and no non-determinism, the system's ready to launch. Now, how long does that take? Anywhere between 3 to 5 months, depending. So expect like a Q3, Q4 launch.
Got it. One last question that a lot of people have been asking me is in terms of, and I know this is a tough question, but in terms of speed, transactional speed, what do you estimate, call it per shard, will be able to be run through CasperLabs? Yeah,
so at the root shard, we should be a couple of orders of magnitude, fully decentralized relative to the full decentralized systems here. So call it in the 1,000 range, 1,000 plus. Okay. Could be faster depending on the hardware that's deployed against it.
Right.
And then that would apply to subshards too. Now, bear in mind, what's pretty cool about this is a shard might choose, they might choose to centralize a bit. There might be actual use cases where they're like, no, as long as all 5 of these guys are voting on this very specific app, we're fine with it being centralized. And then you can get, pretty much as fast as a database once you've made that decision.
Got it. Yep. And is there a limit to the number of shards that can be run off of the main protocol?
Not really. Not really. Naturally, there's no reason for maybe 10,000 flavors of infrastructure. So I expect the free market will force some sort of regimentation. Also bear in mind, people trust shards with more validators than shards with fewer validators. So there'll be a natural migration of like specific use cases. But there's no technical limit. Okay. There's just practical and market limitations that will evolve as the system grows.
Got it. I think that was the only main questions I wanted to ask. Thank you very much, everyone. We appreciate it.
Yeah. Thanks, everyone.
DNA CEO スコット・ウォーカー様。
So that was Scott Walker from the NA and Mr. Mrinal Manohar from Adaptive Holdings.